Good morning. I will present work by Diogo, Lavado, and me at Nova FCT on advancing power grid inspection with machine learning in the context of the ENFIELD project. The central idea is that machine learning can help inspect critical infrastructure more efficiently, but only if it is reliable, interpretable, and useful for human operators. This work, therefore, focuses on 3D LiDAR data, geometric machine learning, and decision support for power grid inspection. Transmission operators need to inspect very long power line corridors to detect defects, vegetation risks, outages, and possible fire hazards. LiDAR gives a rich 3D representation of the grid and its surroundings, but it also produces very large point clouds that are difficult to review manually at scale. We start with the premise that automation alone is not enough. In this safety-critical setting, machine learning should not behave as an opaque replacement for inspectors. Instead, it should help scale inspection capacity while preserving trust in the reasoning behind the results. This motivates the use of trustworthy 3D machine learning for power grid monitoring. The work has three main components. First, it introduces strong data foundations. The TS40K dataset contains 40,000 kilometers of rural transmission corridors with more than 9 billion points and 22 labels. The TS-RGB adds 8,000 kilometers with RGB information and surface normals. Second, several 3D semantic segmentation and object detection models were benchmarked under realistic operational conditions, including noise, ground removal, RGB, and normal vectors. Third, the work develops a decision support tool. Rather than simply producing labels, the tool highlights low-confidence regions, supports human review, and flags vegetation risks near grid elements. The main contributions are better prediction and more actionable inspection. Trust is improved because tower detection is connected to explicit geometric priors, not only to black box statistical patterns. Efficiency is improved because low-resource models and automated triage reduce the need for full scene manual review. Actionability is improved because uncertain regions and vegetation encroachments become priorities for inspection. This work shows that geometric inductive biases can improve both performance and interpretability, with results reaching 72% IOU for towers and 97% IOU for power lines in the best setting. The key message is simple. Trustworthy ML does not replace inspectors. It scales their attention. Thank you.